Hello, everyone. Welcome to this week's binary episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have some exploits targeting XNU, a Chrome heap overflow, and one or two other things mixed in there. But as always, first Z will cover the Spot the Vuln solution for the week.
In this week's Spot the Vuln, may be familiar if you watch our bounty episodes, as this was largely inspired by one of the vulnerabilities we covered last week, which was the mybb SQL injection. As a Spot the Vuln, to be honest, I felt like I should have maybe added a little bit more, so there's a little bit more for you to look at and try and spot the vuln. There aren't a lot of places or a lot of things that can go wrong in this one. But what I've got here is bit of code that does a for each over a post parameter, this custom profile field, gets the column, gets the input as the key value. Does a check if it's string in the loop. It's checking if the input is a string. If it's not a string, it just continues on. So only dealing with string values here. Then it just checks as long as it's not empty. It'll append to this user field SQL. Just appends an end. Then goes database, calls the escape string method on the column, starts a single quote percent, so for the like queries using the wildcards as percent, and then puts the results from another database escape string, this time of the input, into those quotes. The problem here, you may notice, is that if you take a look at the like call, so the second database escape string call, you'll notice that there's the single quote. So that's kind of wrapping the output of escape string. The idea being escape string will escape whatever the input is to be placed inside of a string inside of a SQL statement. The problem here is that the escape string for the column isn't in quotes. Oftentimes columns aren't quoted, but that also means that escape string here is doing very little or nothing. It might be escaping a few things, but it's not inside of the string's context, so you can still include like a space and then go into some completely other condition. As long as you're not using a character that's going to try and escape, you're basically just injecting whatever SQL keywords or comments that you want, giving you a fairly straightforward SQL injection. The actual case in mybb definitely had a little bit more code and was slightly different. Didn't do like the if string check, but this was fundamentally the same issue. I copied a lot of this code, honestly.
All right, so jumping into some topics. Up first, we have a news post by Google on OSS Fuzz and the expansion of its rewards program. For those unaware of what OSS Fuzz is, it's basically a Google project to fuzz open source projects. It debuted back in the end of 2016 and provides like large scale fuzzing for open source projects that they accept, and it's community driven, so you can contribute, projects and harnesses and whatnot. And shortly after it debuted, they established a rewards program to incentivize people to contribute projects to it. There is some criteria there. They have to be, critical to like IT infrastructure and have a large user base. And the payout was determined on how good your integration was. So you would get like a 1K base payout for integrating a project, and then with bonuses, you could get 5K for integrating with sanitizer support, an additional 5K for like efficiency and coverage, and another 5K for maintaining it and updating the corpus, and then finally an additional 5K bonus for projects they think go, above and beyond or whatever. So you could get up to 20,000 for an ideal integration. Now they're expanding that reward program to cover more types of contributions. So that includes things like increasing coverage and what they call notable fuzzbench fuzzer integrations. I don't know precisely what they mean by that. They might have a bit more information like on OSS Fuzz itself. And then the other thing is integrating a new sanitizer that finds at least 2 vulnerabilities. So some pretty cool changes coming and might give some of you out there a potential project to work on that pays decently if you're looking for something to do. They also talk about some tools and frameworks in this post that might be useful to you like for doing this stuff, such as Fuzz Introspector and Fuzz Test. Fuzz Introspector is kind of neat, actually. It tries to provide insights on like where you should work on improving coverage based on like code complexity and things like that. But yeah, I mean, mainly what this post is talking about is just expanding the scope of the rewards program for OSS Fuzz. It is a cool idea, and I think it is a valuable project for security as a whole. So
Yeah, I
yeah,
mean, OSS Fuzz honestly feels like one of those projects that is appealing if you do like the binary level vulnerability research. You can get payouts kind of like a bug bounty for what you do there, but it is, I guess, more also on the dev side. So binary side and more on the like tool dev. Um, but the cool thing with it is also that like when you implement a fuzzer here, it's not like they just give you this payout for actually doing the integration and leave it at that. But every bug your fuzzer finds that other fuzzers aren't finding, you're also getting paid out for that. So it's just an interesting place to spend some time, perhaps get, I mean, a little bit of passive income out of it, assuming you're actually doing something novel enough to warrant like new findings. But it's a project to keep in mind. If you're wanting to spend a little bit of time doing something, it kind of gives you a little bit of a monetary incentive on doing that. Current exploit asks, I wonder if you can add support for some library if you're not the maintainer of that library. I'm not actually sure about that. I mean, if you're going to start maintaining the integration with OSS Fuzz, you might just kind of de facto be making yourself one of the maintainers for it, but I guess you're not officially a maintainer. Yeah, I'm not sure. I guess I usually think about OSS Fuzz a bit less in the sense of going and implementing a project into it, and more just about the fact like you can improve the fuzzers and do that development work. I'm not too familiar with kind of the flip side of that, integrating a project into the fuzzer, although that is something that's kind of covered here.
yeah, I'm assuming it has to do with the license. Like if it's like an open or I can't think of the license names right now for some reason. I'm having a bit of a brain fart on that. But yeah, like some of the more open licenses, you probably could. That said, I'm not like a IP like copyright lawyer or anything, but yeah, it's an interesting question. I'm not sure of the answer on it. But I imagine as long as the license is somewhat permissive, you probably can integrate support into OSS Fuzz without being the main like a maintainer. But
Well, I guess with that, with OSS Fuzz, I think there are going to be some changes that would need to happen on the library side too to support, because it does like the continuous integration aspect with those other
yeah,
libraries to build them. So you would have to at least be able to commit into that other library. You couldn't just like pull your own version of the library and fuzz that.
yeah, for obvious reasons. All right. But yeah, not too much to talk about there. Just wanted to, do like a, announcement of it, I guess, give us some attention because I think it could be interesting to some people who are interested in the binary podcast.
Yeah, and I'll also just add a Rudimal called out one aspect here, which is this paragraph that says we've operated this successfully for the past 5 years, and to date, OSS Fuzz reward program has awarded over $600,000 to over 65 different contributors. And I agree. Rudimal mentions there. I'm surprised that so few contributors. That's 65. And that seems to be for the past 5 years. Like the 600,000 across that. Like that is a lower number than I would have expected. Thinking about it,
I mean, this kind of fuzzing research is pretty niche,
yeah.
so it's not super surprising to me.
Yeah, like the main place I actually end up seeing a lot of that being done is when I'm reading like fuzzing white papers and academic papers where they're integrating with OSS Fuzz. Um, which I mean, there aren't that many papers that are actually doing, I guess, a good. I mean, don't get me wrong, there are plenty of good papers out there, but there's a lot of fuzzers out there that don't actually tend to find a lot in some of those papers I've read.
Yeah, yeah, fuzzing is kind of an art form, and it's difficult to come up with novel research in it because it's been so thoroughly explored for a lot of projects. So yeah, it's not too surprising for me. All right, so we'll jump into some vulnerabilities now. Next up, we have a very old heap underwrite vulnerability in XNU's data link interface layer, or DLIL. And this bug has been in XNU for 19 years. And the root cause is basically an int overflow or an int truncation issue when creating an interface. So for those of you that can see the stream, they have a bit of code up here that's relevant. You can see when an interface is attached, it'll try to get the next index, put it into a signed 32-bit integer, and then later on, when it actually stores that index into the IFP, it truncates it down to a uint16. So if you can create, hex FFFF interfaces and then create another one, that final one will have an index of 0 since it'll overflow the width of a 16-bit integer. And when ifnet attach goes to write the if address later, there's some weird semantics there, but basically there's two objects that are used for tracking. Like there's the ifnet address and then there's the if index to ifnet. And the ifnet address is indexed through if index -1. So when you cause that interface index to be 0, -1 will go out of bounds. In the negative direction, so to speak. Now you would need to be root to exploit this issue, and while in many cases that kind of kills the purpose of exploiting the vulnerability, on XNU and Apple stuff, root isn't the end-all be-all, so a root to kernel privesc would still be valuable in some way, shape, or form, as I understand it. Obviously not super valuable, but there is still a bit of a privilege barrier there. He also speculates it might be possible to exploit this over USB, by pretending to be 65,000 NICs, but practically that wouldn't really work because it would take hours for that to happen, and then Apple also now requires the device to be unlocked to approve connection from USB, so you couldn't just do it from a locked state.
What if I just happen to carry around 65,000 network adapters?
Yeah, I mean, maybe.
In my
That
back
said, it would
pocket,
probably
that's
be
what I'm
tricky to
thought.
exploit it from that context too.
Yeah.
So
Yeah. That said, the bug, the fact that they do this kind of double indexing, where they have the two values that use the same index in different ways, that's just kind of sketchy to me to be doing that in the first place. There is probably a reason for it, but seeing that is definitely something that would kind of pique my interest a bit, I guess. Just seeing the fact that, oh, they're using the same value, but one, you've got to remember to always put it negative. Now, in this case, the vulnerabilities and what I'd probably kind of hunt for with that. Although he kind of calls it out at one point there, mentioning the fact that they load this into an integer and then store it as the unsigned 16-bit. That kind of truncation that happens, the integer will never have the range going beyond 16 bits, so it shouldn't really why do they return as integer? He does raise that as a question. I mean, we've talked about signed versus unsigned before, and I think there's value in having kind of being able to do this -1 check to check on the error, but yeah, let's see if I can find. Yeah, he mentions here, it seems that we agree on the correct fix, although it's strange to keep the return values in. I could see keeping the return value assigned, but yeah, when the size can't go over, does feel a little bit weird to me to do, really just to do the truncation of it. To turn it, or to bring it down to the 16-bit integer is another thing that might pique my interest, especially when you see that signed to unsigned typecast. That's just something to keep an eye out for, but really the weird thing to me is the use of the same value in two different ways.
yeah, it's a bit of a code smell for sure. Typically, I only really see these in truncation type bugs in super old code, like early 2000s code for whatever reason. I guess just at that time, this class of issues wasn't really thought about, so they just kind of use types willy-nilly, not really thinking about the implications of them. But yeah, this is definitely one of those problems where it's just because it was inherited from such old code, and when you start talking about the network interface layers and stuff, that's code that nobody wants to touch. Nobody wants to break that code, so it makes sense to find this kind of issue there. Um, Exploiting this issue was very tricky to do. Unfortunately, he wasn't actually able to take it all the way, but he does go into what he tried. So getting into some of the challenges there, for one thing, the array that you can go at a bounds on, being that ifnet addresses array, um, it it'll get reallocated when it hits the limit for that bucket, and when it does, it doubles the space for the allocation, right? So it's doing that double indexing, so it gets pretty large. And while you can do large memory allocations via kalloc large and XNU, it directly allocates from the virtual memory subsystem, and it doesn't go through the heap allocator. So massaging the heap to get something useful adjacent to that IFNet addresses array that you can utilize the out-of-bounds write on is pretty difficult. A little further down, he does like a list of all the conditions that you would need to meet to really exploit this. So obviously you need an allocation that you can trigger from user space. Ideally, it would persist. That way, you don't have to race like the allocation being freed and something else stealing it or something. It also has to be large, like greater than 1 MB, and it has to fall into this kmem range ID pointer 0 range. I'm not sure what what the deal is with that. It's something specific to the XNU memory allocator. And then on top of that, the allocation also has to be multiple of a page size. So there's a lot of conditions you have to meet. He did actually find one object that looked promising, being the allocation of the new O files array and fdalloc for allocating file descriptors. As the O file size is 9, which we thought was really weird, and I kind of agree. It's weird to see like an unaligned size like that. But in order to meet the size requirements, though, like of hitting a really large allocation, you'd need to create like 300,000 file descriptors, which is technically possible if you're root because you can increase your file per proc user limit. But even after all of that, all you can really seem to hit are the file flags for the FTP. So yeah, it didn't really seem immediately useful. There might be some way to take advantage of it, but he didn't go any further. He decided to call it at that point. But yeah, I mean, even though the exploit didn't work out, there are some nice tidbits and background information in there. So it's cool that it was included, and it's nice to see what paths were taken, even if they don't necessarily work out. But yeah, it seems like a very tricky vulnerability to exploit, and he concedes there might be a way to do it, but yeah, the exploit here just couldn't make it all the way.
Yeah, that's kind of kind of often a challenge when it comes to these sort of constrained out of bounds writes where you don't really control how far out of bounds you're writing. You can't really target where you're going to write. Because in this case, like you're stuck with writing it have like -1 index. It's pretty far out there, and you've got to get something to land there. And yeah, in this case, that just turns out to be pretty difficult. And that's kind of the case with a lot of those sorts of bugs where it can be really difficult to groom things, especially when you've got just the one right in just the one exact position versus having more of like a linear, just being able to execute multiple times with different addresses. In this case, it's another thing. It's always like it's a network interfaces. It's you can't move that around too much and like get the array put somewhere else or attempt it with another object or something like you could with a something that gets reallocated more often, I guess.
Yeah, you're pretty limited by the initial object that you're getting the out of bounds right on. Because it's such a weird object, you don't have a lot of options. So yeah, and like
Yeah,
you
I
said,
guess
that's fairly often the case in these kinds of areas.
like even if you could have hit this without all of the reallocations, like if it wasn't on like only that 600 and or 65,500 whatever, if it wasn't only there and like you could hit it while it's in those smaller blocks or other allocation blocks, you have a few more options. But again, this one's just restricting it. I don't know, it's still, I think it's interesting to see his attempts at it and what he tried. Even though it didn't work, it's still really nice to see that information, because I mean, you learn a lot even in failure.
Yeah. All right, so for our next vulnerability, we have a Chrome heap overflow that was found in the wild by Google's threat analysis group. This one's coming out of WebGL. The POC is pretty funny with how like short and simple it is. For those who can see it, you can see it's just like 4 lines. They just like create a canvas and a document and get a context and then blend colors on it. So fairly simple POC. The vulnerability and how it works though is pretty interesting. And it basically has to do with the texture manager and texture objects for OpenGL GLES. And the fact that while usually the max number of mipmap levels for a texture is computed in the texture manager and is set using this max levels for target function, which is responsible for initializing the level info vector. Um, so like in normal cases, everything is kept in sync. Um, the vector size and the max levels is going to be kept in sync there. But in the case of textures being created from a shared image, it sort of bypasses the texture manager and manually sets the mipmap level to 1, which is a problem because the texture manager's valid for target routine is typically used for validating any accesses using the mipmap levels. And because the texture manager wasn't made aware of the max levels being changed to 1, it could allow out of bounds access from certain methods. The one they call out here is texture set level cleared, which would try to fetch the texture level info and use it to update the texture info. Can't really comment too much on that because it's getting into the specifics of GLES, which I'm not really familiar with, especially in the context of how Chrome is using it. But yeah, I mean, it's basically just that kind of side door issue where you have this special case that isn't going through the texture manager, and so it's easy to violate some assumptions there. The fix was pretty simple. They just introduced a new function to check the size of the level infos vector before calling valid for target at any of the call sites. So it was a fairly simple fix, but yeah, I mean, again, just one of those issues where a special case wasn't considered properly for dealing with these textures. Um, they state that this was like fully chained. Since you have a nonlinear buffer overflow with a controlled offset, it's a fairly powerful primitive to have, especially in browser, as I usually say. So they were able to derive an info leak and run a ROP chain and everything from it. As per usual with the Project Zero and the Wild Post, they speculate on how this could have been found. They think it's likely it was found through manual review, um, just because, like, finding the mismatch between the hard code and max levels argument seems to be sufficiently interesting to attract a reviewer's attention, is what they say there. But they say it could have been possible that it was found through like a custom GPU interface fuzzer that was targeting GL in the context of Chrome. But yeah, they think it's more likely it was found during a manual review. So yeah, I mean, pretty interesting bug. Don't have a ton of information on it, but we do have the root cause at least. And as I always say with these browser bugs, could be fun to see what you can do with it. See if you can take it to a full exploit too, if you're bored.
Yeah, the root cause, and I mean, fairly powerful primitive. Like, a lot of browser bugs tend to get pretty complex here, whereas this is the exploit chain seems like it would probably be a bit more straightforward than a lot of what we've seen in the browser.
Especially with Chrome. Yeah. Jumping back a little bit, Rudamal says this is for the OSS Fuzz topic. He says you do have to be an established project committer for new libraries. But you can still increase coverage for any of the existing ones to get up to 5K. Yeah, so to be eligible for like the full ideal payout, you would have to be like a maintainer of the project, I guess. But if you want some of the smaller contributions, like in improving coverage and whatever, you can still do that outside of the maintainer chain. So
Yeah, and
yeah, it makes sense.
depending on how they actually judge what's considered good enough for the coverage, like there might be a lot of room for that, especially when you look at we talked about I think it was an OpenSSL bug. One of the certificate things. I feel like that must have been OpenSSL.
The
And
X509
like,
stuff.
yeah, and the fuzzer
Yeah.
there, that was integrated into OSS Fuzz, but it was like not hitting that code whatsoever, and like at a very high level, it was just missing a lot. Um, so I feel like if that's an example of what a lot of the projects are like, you might be able to claim a few of those with not a. Okay, so he mentions Rudimo mentions a maximum 10% increase of line coverage, basically,
Minimum, yeah.
or minimum. Sorry, yeah, maximum. They won't pay you if you give it too much improvement. Yeah, I don't know. I mean, honestly, OSS Fuzz is something I've considered like taking some time to spend just to see if I can get some money out of doing that. 'Cause, I mean, sometimes it feels like you can get a decent pay just from that bit of work. I'm probably underestimating some of that though, but I don't know. I think it's a cool project from Google, so we gave it that shout out.
Yeah.
Although another thing saying no 1,000 per 10%. Uh, so if you're interested, you can take a look. jumping, I guess, wrapping up on this current bug, there was also the question, this is an iOS bug, and I mean, considering this is Chrome and on iOS it's all running Safari, I don't think so. I think this is mostly going to be Chrome on Android. So OpenGL or whatever, I believe is mobile thing. I
Yeah,
guess,
so like
like,
GLES is for GL for embedded systems. So
yeah,
typically you'll
right.
see it on like mobile and IoT type shit.
Yeah,
Yeah.
I knew the ES had some meeting like that, but I couldn't remember what it was. But yeah, so I'm guessing this is more like Chrome on Android, uh, rather than browser or iOS, because we still don't have real Chrome on iOS.
Yeah. I mean, there is a bit of history to Chrome where Chrome like Chromium forked from WebKit, but that was long ago. And something like, GLES would probably be like not something that was inherited from WebKit. So yeah, probably mostly an Android thing, not really iOS. But yeah, not too much more to say on that one. For our final topic, we have an out of bounds read that was posted by GitHub Security Lab in cmark-gfm, and I'll let Z get into this one.
Yeah, and this one's just kind of fun, relatively easy. Vulnerability here. It is a out of bounds access where you've got this validate protocol function. And the idea of that is it's taking, in their example here, they've got this like to kev at example.com, that's to colon, then the email address. The idea of validate protocol is that's going to take in a protocol. So, like mail to, for example, would be a protocol in this case, and it's one that it actually looks for in the source. Then it'll take in the data and it takes in this rewind. The rewind, the whole system here works a little bit weird in the way that they're accessing, like in data, they're doing, take a look here, as it's iterating over the length of the length here is the length of the protocol string. It's going negative rewind minus I. So kind of accessing it like backwards as it goes to the length. It's starting off, should be pointing, when you take minus rewind, minus rewind. I can't remember if the minus one, in the other code, it does rewind minus one when it ends up swapping and make this call. Either way, it's basically working backwards from that colon, comparing those characters one by one, from the protocol string. The problem is that it doesn't know where data, or it doesn't have any check to make sure it doesn't go out of bounds of the actual data allocation. So in this case, even though it has the string just to and then colon, if it's comparing that with this string mail to, it's going to, compare the colon, it's going to compare the O and then the 2, and then it's going to go for, the letters of mail. And it's going to compare it out of bounds ahead of the buffer, which is a little bit of an interesting place to go out of bounds rather than after the buffer. But yeah, so it ends up going out of bounds. They don't think this is exploitable. Mentioned here at the end, we believe this bug is harmless in practice because out of bounds read accesses the malloc metadata. It's a heap allocation. They're going out of bounds ahead of it. So at best, they're getting that metadata, and it's not really doing anything too important with that. You'll get the return. You could maybe, I don't know, Spectre, if you've got any ideas on how one might be able to exploit that. I could imagine, if you repeated this multiple times, you might be able to get like a timing attack style thing. But because it's parsing this as like a big blob of text and it just gets to that, I feel like that sort of attack is almost completely unreasonable and unlikely to work out, because it's not like you can just cause the function to be called and do a timing attack.
Yeah, like at best you're looking at like a timing based side channel, but like it's a very bad one
yeah, you
and
don't
like not
have.
useful.
I mean, this is, I believe it's marking, or sorry, it's reading and parsing like Markdown. So this isn't something where you're like feeding it a bunch of text and able to get it to repeat it or something. Um, so I kind of agree. This one doesn't seem super exploitable. But I will say this whole code pattern of using like the rewind and iterating the string backwards to do the comparison, it is just so non-intuitive Like, again, this is the sort of code that just stands out as like, what the heck are they doing and why? And part of this, like, part of what is going on with that, um, it just has to do with how they're actually processing all of the strings, and it kind of makes sense in their post processing that they're doing this sort of rewind thing. But it really stands out as something kind of weird to at least look at and make sure they're getting right, because it is very unintuitive to read. And so anybody who's going to be thinking about this from a security perspective, or even just writing the code, they may not be able to compute it or keep that same mental model. Like, it's very easy to get this wrong versus doing
Yeah.
just a forward iteration of it.
Yeah, and then the nature of the vulnerability is kind of similar to the XNU bug too. It's sort of funny how similar they are, though very different in like their impact and how they could be utilized. But yeah, it's unfortunate that this bug is probably unexploitable. Like there might be some weird way you could take advantage of it, but it's one of those cases where you probably just want to look for a better bug if you really want to hit the target that badly. So
Yeah, and I guess I'll
uh,
mention it only, at least in my quick search of the code, like, it uses this function to check for like mail to as a string in XMPP. So it doesn't have like any big long out of bounds thing that you might be able to trigger something else, because it's going a lot further and out of the malloc or out of the like malloc metadata that might give you something more. Like, this is relatively limited by where validate protocol is being used with these fixed strings for the actual protocol that's comparing with, that decides how far out of bounds it'll potentially go.
yeah, so it's unfortunate, but that's just how it be sometimes. With
Yep.
especially with these text-based parser bugs, it's
Yeah.
difficult to get a powerful primitive in them.
Yeah, even with like um just being in that, like, you're left in a lot of cases with those one shot exploits, which just add the extra challenge regardless.
Yeah,
Just given the type of input it gets.
yeah. And with that said, that's pretty much all the topics that we have for this week for the binary episode. So Z, if unless you have any last minute thoughts, we'll wrap it up here.
No thoughts and no shout outs this week.
All right. So as always, thanks goes out to everyone who tuned in. If you want to catch past episodes, you can find recent ones on Twitch and all of them on YouTube, Spotify, and other links on Anchor. If you want to join our Discord and follow us on Twitter, links to those are also down below or in the chat. And with that said, we'll see you next week.